The example that we're having today is a result of, Sal's looking worried now, as a result of two very good colleagues of mine, one called Mr. Florio, one called Mr. Khan. We're having a Zoom team, well, Sal was with me, but we're having a discussion with Mez, and Mez says, oh, this is really easy, I've got this KNIME, it's really easy, we can do this, blah, blah, blah. And they're all getting very excited about being able to show how bCLEARer works, and rightly so, okay, I mean, this is meant to be a joke, yeah? And what we realized is that if you use some kind of no-code system, it may be possible to get you to, in fact, let me see, I think I actually say it here, is that it may be possible for you to experience the practice of how this process works. So what we're trying to do is recreate like a Disney World version of what the process of bCLEARer is. And we're trying... We did our best, yeah, so if they're going to be perfect because you've only got an hour and a half or something, we're trying to get you to feel, if you're going to do this, if you're going to do a migration, well, in fact, you're not even going to do a migration between two systems. You're trying to go from a migration from the original data to your interlingua. What does that process feel like? And that's what we're trying to do today. And if it's successful, it was my idea. And if it wasn't, I know I can point you at the offenders, yeah? Okay, it's my fault. I'm joking, yeah? Okay, so the other thing is that you need to realize that you're just going to get a feeling. You're not going to come out of... I think none of you believe that as a result of an hour and a half playing around with something that you've never seen before. Well, some of you are probably already experts in this, so you don't need to be an expert. But if you weren't an expert before you started, you're not going to come out. But you should... If you approach it from the right attitude, you should feel what's going on. And I think what's actually happened is, maybe Jonathan can talk about it, but Jonathan actually took the example and worked through the example, and I've been quizzing him, what does it feel like? And the feedback I'm getting is he's beginning to see how more and more how it fits together. So our initial experiment with the guinea pig seems to be that it is useful. Okay, so there are two examples, lump of clay and ISO countries. I think I would try and get the first example okay, but maybe some of you are going to be so brilliant, yeah, that you do that in the first half hour. If that happens, you've got another example to work with. So you can't go home, you can't go and have a cup of coffee, you've got another example. There are, I've called them the summer school tools. I was trying to explain it. So what we've done is, anyone who worked on a large project know what happens. You do all these large projects, got brilliant ideas, things work certain ways, and then afterwards you try and rationalize the processes you've got. That happens again and again. Every project you come up with slightly different tools. So these are the tools that we've come, and then we've tried to explain to people. So over time, these are the ways we've packaged it. We were packaging it with not enough funds, not enough time. So the packaging is less than ideal, but broadly these are the right sort of places to go. We're reusing stuff from previous tutorials. So these are the things that give you a feel about the kind of things you might be doing. When you become expert, you're going to do it your own way. I mean, that's the way people are. So this is not like these are the only way. Well, there's some kind of there's elements of prescription in here, but when you understand it, you'll know what to do. So and the last thing is that again, I was in fact I should go back to here just to make sure on the list. There's a whole group of people. Here we go. There's a whole group of people who've been working on this who are to blame if it goes wrong. Yes, just to be clear about this. Including Jonathan's up there. So if you want to do it in person, me and Jonathan are the people to blame. So okay, so this notion of shift left useful, I think there's not much on it if you Google stuff. There's stuff, but not a lot of stuff. It's a big, as I said, it's being embraced by data engineering. The idea is, well, in fact, it's now being, Jonathan was saying, it's now being embraced in engineering. Engineering's got shift left. So I think they've taken the label without quite working out what it means. But okay, that's a different point. So the thing is that if you start with unstructured text, you want to get it structured as soon as possible so you can be in machine-to-machine land. So you're shifting the point at which you're working with machine-to-machine stuff is as far to the left as possible. And I suspect that if you're a logician and come from that world, and some of the maybe the more, I don't know what Stefano, maybe the Dolce and UFO people probably are more used to working with text at the early stages, no? Or is that unfair? I mean, some people are more used to, no? Or, okay, yeah. Neither violent agreement nor disagreement, yeah, okay. So in our world, we would, we really, just because you want the machines to do stuff partly in volume, we would structure everything. So we're trying to go to simple tables. Here's a graphic, which of course explains everything. You look at the graphic now, you understand everything. Yep. This is what a table looks like. Well, actually, it needs to have column headings, but everyone knows what a table looks like. Trying to actually formalize what a table is quite an interesting exercise. You can do in your own time. So we start with the unstructured text. I think this was sent round. Yeah, sent round. By the way, the bit that we're going through, we do for you. So we'll give you the table. So it's not something you have to do, because we're trying to prioritize the time. So for you to get this practice on dealing with the process, I'm just telling you what we did. So if you look here, as we take this and we put it into a series of tables, lump of clay appears. So you put statues appear here, statue destroyed. And one of the things that was quite interesting is that when the team were working on it, they were really tempted to put an interpretation in. So they got more and more complex set of tables. So they actually went to the end with all these assumptions of ontologization. And in fact, the first time I looked at it, I thought, this is brilliant, well done. And then, we've not done it. We put a whole set of interpretations on it. And the interesting thing is I said, what happens if we're going to do a BFO on this? And we couldn't do it because we dumped BORO into it, yeah? And so, anyway, I'm not saying that the job that we've done is brilliant, but it's certainly better than the first job. And we may well have done the same thing. So if you want to make your own table and do it in a different way, that's fine. I think I would prefer you to work on the process, but I'm not making any claim that this is the right way of doing it. And the indeterminacy of doing it is quite interesting, because it's part of the problem when you work with unstructured data. One of the other things that we did, and if you like, I talked about smells. If you're in the code land, you talk a lot about smells, is that you would never see in a database T1, T2, T3. I've never seen in a database. If you have, I really like to see the examples. So what we do is we were argued about it, about whether, sorry? No, you argued about it. There was we did a granularity of a day. It could be a month, it could be a year. Different granularities, different. It could be a second, it could be a microsecond. We went for a day, because it doesn't matter, we just shoved it in. This is the other example, it's structured data. Sure, go. I didn't catch what you said, I'm sorry. No, we don't want to assume anything. So, okay, so this is, Giancarlo says this thing is every system has an ontology, and I think that's sort of true, but what's interesting is I think they don't make the metaphysical choices. So I think I've never come across an operating system where it is, or you could assume that because the way they've structured it, they may have made something, but they may not, yeah?
Let me rephrase my question. If you assume supersubstantialism...
Nothing. Remember when I said about this computerization stage? What we're trying to do is, most systems, when you engage in the commercial world, I would be really interested. I know some of you here work with systems. I can see that you've got systems, and particularly if you do these time series systems and other things, you can see they've got an inherent 3Dism or something like that. But it's like a half-baked attempt at it, yeah? And you could interpret it another way. I think that most data that you start with in our era, maybe in 10 years' time it's different, you have no idea what choices they've made. And you can try, what the trick is, to try and create a data structure, which is what we were doing, where there are no choices. We're not making any choices whatsoever. So what I want you to do is to start thinking about how you change it. So maybe it's going to be difficult for you. I want you to be BORO. I want you to be super substantivalist. I want you to brainwash yourself. I'm a super substantivalist. How would I change this data? Yeah? So that's the exercise, yeah? If you're successful, you get a tick, yeah? Yeah, exactly. But it's more than that. It's what it is you've given this data, you want to build a super substantivalist model. What transformations, in fact, let's go, maybe it'll become clear as we go through. Let me go through, because we've got until 12, is that right? Oh, we have lots of time. Why am I hurrying? This is, okay. I think you're, hopefully, and ask me again if it isn't clear, I think the things towards the end should show you what we're trying to do. But what we're trying to do is we're trying to say, look, we've got no choices, we've no idea what's going on, this data comes in, it's really rough. And in the first stage we're saying, no ontologists allowed in the room. We just want computer scientists. You've got to make your data clean, and that's the computerization stage. Then we leave them in the room, but we say, go to the back of the room. Now we bring the ontologists in there in charge, and the trick is, we're not asking them, you tell me human to human how it is. We're saying, you tell me how I change the data. So after I've done all the translations in the data, what I've got is now my inventory of the things in the world if I'm a super substantivalist. And I think that the trick is that's what you need to do. And I think, I was particularly impressed when Stefano was doing your answers. You had a list, you had an inventory at the bottom. So this is a really, if you like, more rigorous way of, I'm not trying to say, it's less rigorous in the sense of logic and stuff like that, but more rigorous in the sense that it has to be the list, it has to be all the objects, you have to say where they come from. So there's a different kind of rigor, sort of a process rigor about what's going on. You want to know all of the things that exist. Okay, so the other thing is that because we've got this, engineering's about design compromise or design trade-offs. So you want everything to be machine to machine. You've seen these arrows going down. One of the things that we need to do is we want to have the top level tables in. So what we need to do is we actually introduce, and here's a meta schema for what's going on. This describes the tables that we introduce that you're going to, this is, if you like, the format of the inventory that you're going to have at the end. Yeah? So you have sets, if you look at the left. I keep on pointing to my screen and wondering why you can't see what I'm doing. So, Sal, is it the thing at the top? Is it the red button? Yeah? Okay, I can see it now. Okay, so there are sets, individuals and tuples. So those, do you remember the three categories? And these are the four grounding relations. Yeah? And this is a pure version. And what we do is we set up some sort of structure to be able to store it. So this is some structure to be able to store the data. It says pure. Is that what we've done here? And we can, if it's not play, where are we? Where's my? Have I lost it? I can't see it. Okay, what we've done is we've actually dumped the places into, so if you look at the third row, it says tuples, is we've put the places are rather than having separate places. So when you're dealing with data, you can have something that's more verbose, but it's really hefty. You could use either. This is much, much easier, and we've given you this as a set of tables. So we've given you this, and we've actually loaded it into KNIME, and we've loaded it into the Excel spreadsheets, I think, for you to play with, yeah? In the input data. Okay. So, I've given you an enormous amount of rhetoric about everything should be machine to machine, yes? So I want you to bear with me for a second. So now I'm going to give you a lot of rhetoric about do something with human to machine or human to paper, okay? When we do this process, we do go outside and we do play with our models and everything else. But in a sense, that's a preparatory exercise. We try as far as possible to do the machine. For this summer school exercise, given the amount of time and everything else, it is actually easier to use, I don't know what's paper. When is paper? 11th century technology. Or if you put writing, sort of, 9th century BC technology to do this sort of stuff. Sorry, is it? Yeah. I'm getting feedback. So what we've got is when you start off, you find that your design for what's going on doesn't fit. And so you do massively more iterations. And on a small exercise like we're doing now, it's easier to do the iterations on the whiteboard or pen and paper. And I was watching you over the days in your classes, you do the iterations. So this support process I'm now doing now is a way to get you started thinking about the pipeline. Let's hope you have time. Certain people have expressed doubts about whether you'll get to use the KNIME. It would be great if you could prove them wrong. It would be really nice to try and work with the KNIME. Jonathan's around. Where's Philip? Philip, yeah. Is he? I can't see. Oh, he's here. Okay. Rebecca, I think, am I putting you on the spot? She's got KNIME up. There are various people who've got KNIME up, so they can lend a helping hand. I need to admit, I'm a Python, not a KNIME person. I will help, but I'm not sure my help will be useful. I can call a friend. In fact, I've got 2 friends I can call who could help you. But it'd be really good if you get to the KNIME. And the thing that you want to do when you do the primary process is that what you need to realize is that you can run it as many times as you want from start to end. And I'll show you, we'll talk about one of the manual Excel processes. Running it, changing it is slightly easy. It's intensive. So when you run the KNIME process, hopefully it'll run sub-second. Jonathan, yeah? Yeah, it'll run sub-second. So you'll see that it's executable, obviously repeatable. It's as inspectable as you design it. So inspectability is a big issue. I could have done the whole summer school thing on how you should put inspectability in your process and the ways in which you need to do it specifically for doing this kind of ontology work. We've done a lot of work on that. But I think at least at a minor level, you should see that whether it's inspectable. Oh yes, so probably I should have gone with this. So these are the processes here. So structured data table is SDT. So what you're going to, in the end, the idea is you take your structured data table, you put it, the BKNDP is the KNIME process, you shove it through these 9 processes, but the space-time map, the OED, and the BUML are mechanisms that help you design what's meant to go in there. I'm hoping that you find the STM and the OED relatively easy to do, and it'll be interesting to have feedback. If you could, you can tell me or Jonathan or Phil or Rebecca how easy it is or how horrible it is. If you want to vent your anger because it's so awful, please do so. We want the feedback. If you try and schedule your afternoon, I think I say this later, try and schedule your afternoon so that you can actually do the KNIME, that would be very, even if you do the Excel, so BXTP is the Excel, even if you can only get to do some of the Excel, that you get some sort of feel for what's going on. And for the non-IT people, I'm going to try and explain what we're doing. What would be really interesting is, particularly if you come back, if there are barriers to, if it's difficult to do, and particularly if it's difficult to do because I've explained it badly, I really want the feedback, yeah? So, okay. So this is let me see if I can do this here. So, okay, so again, I've fallen in love. Peter and I are in love. I don't think his wife knows about this. I don't think even he knows it. But in his 1990 paper, he draws a space-time map. Yeah. Now, there's actually very few. I only found this recently. There are very few. We did lots of research. Okay, so if you're a mereological extensionalist, space-time map's brilliant because the two-dimensional surface of the page, the mereology of the page can be a representative for the mereology that you're trying to represent. So you've got this in perfect, apart from the dimensionless, you've got this perfect harmony of the mereology of the representation and the mereology of the represented. Yeah? And in fact, if you read the text that's associated with it, he uses that, but he doesn't go into quite the sort of detail that we do on this. So let's go through here. STMs focus on individuals. The things in the STM are the individuals. You'll have labels that indicate what types they are, but that's just if you like, what's the word? Sugar, not syntactic. It's some kind of a ontological sugar to know what's going on. You really, the meat of the thing is the mereology of the page should in some way mimic the mereology of what you're trying to represent. You're looking at overlap and parted relation. So if you claim there's an overlap or parted relation in reality, there should be the same overlap or parted relation on the page. There's some minor things to do with how you handle borders that you need to worry about, but I think we'll probably have time to talk about them. Yeah, okay. And historically, intriguingly, this is for non-philosophers, for IT people working the data things, people find this really useful. They think it's very explanatory, sometimes in ways that are unexpected from what I'm doing. Okay. The other thing is that you're not focusing on the whole domain, and in fact, I think we're going to there's probably going to drop a manual for something called SDMs, which are space-time domain manuals. I can't remember exactly what the terminology is. And the idea is you can have a set of space-time, intersecting space-time maps that cover the whole domain, that give you a picture of the mereology for the important elements of the domain. And so one of the things you're trying to do, it's not something you're worrying about now because the example is so small, is you pick and choose which bits of the mereology you want to talk about. Okay, so it's four-dimensional with time. Yes, so this is where you go down. So what you do is you collapse, and Iwagan says the same thing. He tries to do 2 dimensions, x and y in here, so he's got what is this picture here, but in reality, if you ignore x, t, and z, ignore the z-axis, you've got your y-axis, your x-axis is your space axis, and your t-axis is your time axis. I wonder, let's see if I can get to a space-time map. Yeah, okay. So this would be a space-time map here. You normally have space going up the page, time going across the page. You draw boxes for your individuals. And this would be individual 2 as part of individual 1. These would be the times it starts. If the box has if it's a rectangular box, the left and right edges are the start and end because of the way time works in terms of what's going on. Oh yeah, I wouldn't worry too much about, you're going to get a copy of this, I wouldn't worry too much about the details of, I'm trying to think, the details of the, that are down here below. You can do it on paper, you can do it on a whiteboard. If you're lucky enough to have some people who've already done space-time maps, ask them for help. I think this is easy. Let's see how easy you find it. Maybe you need no help. Oh yes, there we go. It's talking about if you like, the structure you're doing. This is, if you can go back to, in this case, to 1817, people talking about the different ways you can, the objects can interact. I mean, it's a standard different shapes in mereology. You'll see this in any and all mereology textbook. And the idea is that the box, because you've only got we've only got this one dimension for space. It's meant to represent the 3-dimensional space, and this the right to left axis is meant to represent time. You put the way so these instructions here are, if you are doing it in PowerPoint, we're trying to make it look consistently as you have a border around a box to represent an individual, and then you tend to label the individual so you can see it. And I mean, I'm sure you want to be inventive and pick your own ways. We try, for our stuff, we try and have a consistent set of way of doing it so the things look consistent. Okay, I should probably move. Okay, so when I first started this, I wasn't as clear about the difference between Euler and Venn diagrams as I should have been. Now I've been told there are lots of jokes about it. In a Venn diagram, you have to show all the combinations, even some that are impossible. So exactly, which is the example you see on the left with animals and mammals and birds. With an Euler, if there's nothing there, you don't show it as a space. What this is trying to do is trying to get the equivalent of space-time maps for classes here. It's you have the same, I talk about this in the 1996 book. You have the same sort of, it's Lewis and parts of classes. You have the same sort of mereological features, bog standard. I mean, maybe some of the details are different when you drill down, but you have the same mereological sort of structures of overlap and part and things like that, and distinct for classes as you do for individuals. It's just the same sort of things we tend to do, because when you're in the, if you like, set land, you're less worried about time in most cases. So we just have this way of drawing things. So there's an idea of a simple. The reason that they're called extended is that you can, if you want to represent sets of sets and you want to use the mereology of the page, the containment of the page to do it, you've got to be able to have 2 ways of representing. So what happens here is we're saying you can see the set as if you like, on the left as a many and the set on the right as one. And what that means is that if you want to try and do things like power sets and stuff like that, this might build actually, you have a way of doing it. And we have a special, because we not so much. Okay, there's an interesting relation between power sets and the way you do construction. They're not quite the same. Power sets don't emerge in the same way in a constructional view as they do if you do a straight sort of Boolean power set, but you still want to know the power sets. They're useful to know. Oh yes, it's building here. So let's go back. So basically, one of the things, you won't need to do it in the example, but we have, just like a UFO does, but unlike Dolce and unlike BFO, well, I think you said you may be changing, but we have higher order types. Set theory has higher order types. So if you take set theory, you take higher, or we don't have higher order sets. Let's zoom. Where are we? 10 minutes. Let's see if I can do this. I probably need to zoom. There's this UML. I'm going to zoom through it. It's just boxes and arrows. It's most of you will know how to do it if you've got any UML. We can take more. There are standard patterns that keep on repeating. Anyone who works with this kind of stuff does patterns, and I think the others have talked about this quite a bit. You can see, if you like, this is trying to show how if you do a space-time map, which is on the right here, you can translate it to BML. There's translatability. Okay, so what we're trying to do here, if you're interested in IT architectures or the way IT work, there's this talk about the difference between monolithic and microarchitectures. So where you have a single big thing or where you split it down. And typically, historically, originally, I think it was first used as a distinction between running an application as a set of microservices rather than a single big application. But it's actually been taken up in pipelines with this idea of microtransformations versus a single monolithic mapping. And I think that what you're trying to do is as it says here, you're trying to aim for maximal inspectability. And if you have a lot of small steps, you can see what's going on. Also, and I've got a whole lot of literature on it, there's this thing you scale down to scale up, is that if you scale down to the micro level and separate out all of the components, those things that you separated are more likely to be reusable. And hopefully that'll be clear as you go through the example. Repeatable, reusable patterns. So, one of the things that we're doing, and I think this has been done for you, is the first thing that we want to do is BIE means Borough Identity Ecosystem, and there's a whole raft of stuff that on this. I don't know how much we've got published on it, but anyway, we're building an ontology for data and a way in which the identifiers hang off the ontology for data. These are based on base 32 IDs, I think. I'm trying to remember, are they 13 whatever. Anyway, you've got a set of these, you've got identifiers. Basically, you want to put identifiers on the, okay, they've used a different one. That you'll have work, this stuff should be in the example that you get. These things here are from the actual, these aren't in your Excel spreadsheet, which you'll get, is you should get this load. You won't have the early evolved stages. This is part of the work you intended to do. But these pictures here are from our answers. And part of the reason is to give you some sort of feel what's going on. So one of the things that we're doing here is we're doing a column split. So if you look at the table, I wonder if I can get this to, let me go here. Let's see if I can get this to work. Can my eyes go, can people see, anyone see you can see it? Okay, thanks. Maybe I should get someone to do it. So, these are the BIIDs. So what happens here is you're doing a split, but you want the rows to go across. So the rows go across to here, and I think they go, where are we? Go across to here. These two columns, B and C, go down as B and C here, and D goes to D. You can't see E over there. That's missing. They go down to here. But, okay. Perhaps it's worth taking a second. So what I'm splitting here is this thing here. There's a semantic split going on here. I'm column splitting. I'm saying this thing here is the statue that I'm taking out. Here, I'm taking out the relation from this thing here to what it's been made from. So what I do is I have, these are new BIEs that I'm putting out, but I use that BIE here and that BIE here. So what you're doing is that if you think, if you have a table, you can slice it by row or columns, and you just need to find a way of preserving some of the semantics in the way you slice. And in this particular case here, we're saying we think that the first 3 columns, A, B, and C, are related to being a statue, so we're taking them out, and then what the other bit is there, so we're slicing it down to try and make it clearer. So you could see that if you've got you could think about it if you're an IT person, if you've got a table with some foreign keys in it, what you could do is you could rarefy the foreign key on a separate table by pulling it out. But you need to have the ID of the originating table as well as the foreign key. So it's like rarefying a relation. 5 minutes, okay. I'm going to, and there are various other split patterns. You can split rows. This is the implicit foreign key that we talked about, and there's 2 stages. One of the things is a push down. So what you're doing here is you're taking the table names, which have some sort of identity, and pushing them down into the rows. And I think, oh, you're here. Okay, so I don't know, should you do this, Jonathan? Okay, go on. Yeah, okay. Of course. No, come. Do you want this? Uh-huh.
So I would suggest to call it a business object reference and general ontology,
Uh-huh.
which gives you a much better argument. That's good. Okay, that was the joke. Now the second one, this is back to 78 on the last...
Okay, should we go back?
Yeah, maybe a simple line.
Yeah.
So I wonder exactly what you mean by data.
Oh, you've asked me before.
What do we have here? Can you tell me?
Okay, so can I do something? So that is a really profound and really, really difficult question. And we spent the last, actually, I know when we started. So we spent, actually it's more than 18 months because Anne was still working on it. We spent the last 2.5 years worrying about it. And I had a really interesting session when I went to Buffalo. There's Oliver, I don't know. Kennedy. There's a really knowledgeable person, Oliver Kennedy, who's talking about database and the way they do database identity. And I like to steal other people's ideas, yeah? And I'm really annoyed because no one has got any good ideas about data identity. So I mean, I would need 3 hours to make you happy with an answer to the question. But you're right to we're assuming that if you're in IT, you have an intuitive way of dealing with this. I think let's see what people do. People who work in IT, they will have a way of dealing with it. I think you're right to ask the question, and I think we need to look in the literature, and we need to say the literature is not giving us the right answer, and we need to apply formal ontology to data, and no one's done it. And in fact, if you look in the 70s and the 80s at the database books, I'm using up. Are you, Sal, going to give us 2 more minutes? Okay. Is that if you look at, I did this exercise, I have about 150 books, which are all database textbooks, and I went through the indexes to go look for identity. The reason I've got so many is anything after 2000, apart from the mention of these URL type identities, IRIs and stuff, there's only like 2 references. They're not mentioned at all. Big in the 70s and 80s. Ullman's got some. In fact, Ullman's writing. It's interesting. Ullman in the 70s, the 80s, and the 90s. It goes up. Lots of discussion goes down. And I think he's got a 2010 where he's like the 6th author and a thing. They don't even mention it. So, and I think it's a. Yeah. I mean, I don't know whether that's. I would like to claim I know what it is. I haven't published yet, but it is not an easy question to answer. Yeah.
I do have a few more slides to get through just to help you understand KNIME.
So I think if people do, we want you to do the KNIME. If we don't tell you what it is we want you to do, you might not do it. But then we do a question, and then it's up to Sal. You have to ask. He's the guy who's.
I've got to follow Chris's pace, so apologies if this is also rapid. So what's on screen at the moment is some of the original data, which has either just been emailed out or will be in the sort of next couple of minutes. And what we're asking you to do is look at the manipulations needed across the table to try and extract some of those sort of 3 onyx at the top. So KNIME is just one way of looking at this. Normal pipelines are done in sort of Python or some form of scripting. KNIME is sort of a no-code environment where you can see the connections being formed across the tables. So let's skip through. So this is KNIME. This is the sort of collect, load, and evolve, as Chris has been speaking through about BORO this morning. And the top left, you shouldn't have to do anymore. So the updated slide, the data is embedded in the file itself. So here, where it says execute all, you should be able to click that and it'll load straight through. Now there are two KNIME files in the zip file. There is one that just does the collect. There is one that does the collect and load. The interesting stuff for me and Chris is the evolve, but you do have to get the stuff sort of sorted in collect and load first. Maybe for the sake of today, just focus on evolve where it's more interesting, and I think we're going to get more discussion this afternoon, but certainly as an exercise later, go back and look at what we've done with collect and load. A lot of string manipulation, basically. So within each of these boxes, so a grey box in the file, you can double click, and then there's nodes that you can drag in on the left. Google is your friend. There's lots of KNIME examples of how do I column split, how do I do this sort of thing. And what you'll see in the collect is we've already got the Excel readers here. So the CSV files and the actual Excel files are being read in for you. And anything that goes out to the right-hand side is now available back at the top level. So out of collect, we've got these 4 lines. They're going into load ready for you. So if you just open the collect file, you can double-click into load and start producing it. Same for the load. So if you open the collect and load file, all of the information's in there, allow for you to start the evolve. You can just work on the main screen, so evolve won't be there, or you can just double click inside. Some of the ones already in there, there's further sub-steps. So it's not one layer in, some of them are 2 or 3 down, just to be careful. And what we're looking for is something like that. So we're asking you to work through the evolve, doing the manipulations that you want to, and there are some things there as a sort of a flow going through.
Yeah, so I think Jonathan's right, but remember he's had 3 days to do this and you've got half an hour. I think what you're going to do is have a mess, but the thing I'd really like you to think about is, have you sliced your transformations down? In fact, to answer in a sense some way Stefano's question, I believe that intuitively you'll find out ways to slice things down. Find out whether they're reusable. So are you using this column slicing and row slicing? It looks very reusable. Try and think of producing stuff that's reusable. And the trick that you want to solve is, remember, you want to develop a set of reusable processes that you can reuse at scale, that are all the processes you need when you're trying to translate the data, the dirty data, or the unstructured, not unstructured, the data you get in the beginning into one that conforms to your top ontology. What are the little steps you need to make? And you really want a very small vocabulary of steps that you can, with lots of composition, you can get to the answer. Okay. Oh, sorry.
There is one last thing just to say. So Chris is talking about space-time map. Definitely start there first and figure it out. There's also the OED, so the Euler diagrams of understanding what's in what sets. The BUML you can probably skip, because I don't think within the KNIME you're going to really start applying it to the top level, but it's there as a for those of you that are more advanced with this stuff. The Excel spreadsheet is still there within the zip file, so you could just do all this manually. We do recommend still having the sort of the last 30 minutes, just have a look at the KNIME and see how you could start to do this computer-to-computer interoperability. And that's sort of step 5 then. So try a bit in Excel, start to get a flavour of the manoeuvres you're doing within the tables as you create the sheets, but then start and try and introduce it into the KNIME as well.
Ricardo or not?
It's your birthday.
I think it's my birthday. It's my birthday. Go on.
Thanks. No, well, aesthetically variable for the state is the data for you, right?
I think what we've got. Okay, so what we've got. Okay, so I think I understand. I think you sound like Stefano. So it seems to me that we. Yeah, the Italians are all the same, yeah? No, okay, sorry. It's really good you asked the question. So it seems to me we've got representations, and text and data, they're just representations. They're just more or less structured, yeah? And for me, data is any representation that can be easily read by a computer. And it's slightly accidental because it's a data in a format that the current computers can, maybe in a different civilization or us in a different possible world would run data in a different way, and our computers would work in a different way. Where computers are formal machines, maybe Turing machines or something like that. So for me, is I've got this representation, and if I look at, in fact, I was talking. Okay, so let me see. This was a late night in a sauna with Stefano. So let's say, Yeah, we had our clothes on. We had our clothes on, honestly. John didn't come down. John refused to come down with us. Okay, yeah. I've got evidence that he didn't come. Okay, sorry. Okay, so imagine you're doing John's BFO example. So you have a table coming in. It's a representation. If you what algorithm? And this, in a sense, I don't know whether I don't understand well enough Stefano's question. We need to talk more. But this is what I said to him. So imagine, or something. You've got something coming in, and you have an algorithm that tries to count the number of objects that are there, the number of data objects, yeah? And then you do, let's do Dolce, yeah? You do something to it, yeah? And at the end, you have your list of objects, yeah? The list, what you want to end up with is that you've got a picture of the world such as there's a one-to-one relation. You've got a kind of a picture theory is your items of data up to a certain level are one-to-one with things in the world when you've finished your analysis, yeah?
Well, I try to formulate the problem that I see.
Okay.
The problem that I see is this one. If you adopt supersubstantialism, you run so four-dimensionalism,
Yeah.
Federalism, you got this problem. If you say that John and only John is happy, and your query is how many people are happy. And you say John and only John is happy. So that's one. If you adopt federalism, the answer that you must give is infinite.
Infinite.
Yeah, unfortunately, yes.
Why?
I think you need to explain why.
Well,
What he means by a query.
Okay, yeah. That's what you mean by a query.
because John is a temporal extended. If there's a temporal part at t, and you are attributing the property of being happy, for instance, or whatever.
In BORO, we don't do it that way. So for starters, you're describing your theory, not my theory. But that's okay.
That is federalism, classical federalism, Lewis federalism. Time t, you have a temporal part, you attribute the property of being happy.
No, that's not. I don't. You misunderstand the way in which four-dimensionalism works. I think that's not the way standard Lewisian four-dimensionalism works. I'm happy to go head to head on this. I can tell you that, and that's not the way we do it. So you're assuming a time t. If you say there's some temporal stage, yeah, so it's a worm theory, not a stage theory. There's some part of the worm which is there's a maximal stage which is continuous, which is happy. Then I agree. You don't need time t.
I think what you're arguing is that there's an infinite number of slices within that temporal stage. No?
Wait. I try to rephrase once, and then if it takes too much time, I should tell.
Yeah.
John is a person. It is a temporary extended maximal.
Sure.
It is a maximal.
It's a person. Person, it's not a problem because it's a countdown. With happiness, because it's a process, you could divide it up. It's different. Yeah.
If we say usually for federalism, if you say that John is happy at t, this means that John has a temporal part of t that is.
We don't do it that way. Lewis doesn't do it that way. Worm theory doesn't do it that way.
That way for sure. I mean, I give you the exact reference.
Good.
1976 and in the plurality words.
I would be interested because I'm reasonably certain he doesn't do it. I mean, I spent ages on this. Yeah. I think you're doing it. You're doing a temporal stage theory, not a worm theory.
No. I mean, the classical federalist account of temporal predication is X is B at t. By definition, means
I don't think. I think in quoting Lewis, and let's go back and look at the text. He doesn't do temporal predication. That's the whole point.
I have it right here. Where's
Do you do it? You with me or are you with him? Okay.
Tell me the page.
I think so, Ricardo. I think this is really, really important. So, sorry, Sal. Is that I think that if you live in a 3D world, you assume that the 4D world. I had the same conversation with Giancarlo. That's not the way Lewis works. Let's look at the text. I'm certain what you're doing is you're projecting your 3D prejudices onto a 4D world. I believe. I mean, I'm happy to go to the text.
Just read the Lewis and the plurality words, page 2.
Let's look at it together. Yeah. Yeah, he's going to look it up. Yeah. I mean, John. Okay.
All right. Let's thank Chris and Jonathan.
Well done.